folks. If you're watching this after the fact, make sure and check the description for time codes. We're going to take about 10 minutes or so to get going here. So, and it's going to be a long stream. So I recommend if you're looking after the fact, check the time codes. I think we'll just get going get everything going. I'll pause all my streams and stuff. If you're in the chat, say hello. I'll start by just saying hello to folks. I think everything's okay, but you know, it's always good to get things going a little early to make sure that everything looks okay. Hello, Keithy EE. Thanks for saying hi. Is the audio and video all good? Is it 2 weeks ago that I had video stuff? Han says, hi all is okay. Thank you. Hi, Neurodoc. Hi, Andrew. Hi, Ismail. Thanks for stopping by. Again, like I said, if anybody has questions, I'm happy to answer those early. Otherwise, I'll do housekeeping in about 6 minutes or so, giving everybody a time to get going. Keith E says, sounds good, looks good, live on Twitch as well. Thank you. Yeah, I set it back. Hi, Beta Graph. Hi, MD Roberts. Hope everyone's doing well. Hams Lab says, hi, Scott. I'm just walking home from a BLM protest. Oh, good for you. I don't know if you know, but we have kind of a standing BLM demonstration. I wouldn't say protest, but like a bunch of people go and hold signs out by the corner and by the corner every Friday afternoon. So I actually usually do that after the stream. I have this sign that we have up in the house that's really awesome that says like, be welcoming, kindness is everything, Black Lives Matter, all that stuff. So awesome. So I'll do that today, later. Hi, Rick. Hi, working well in Michigan. Dotzed. Oh, PT stopped by, I think, saying stopping inside to say hi before meeting for me. Happy 200 boards. Happy 200 boards, everyone. We'll talk about that a little bit. But started early enough for Phil to check it out. There's like an internal meeting like during the stream every time. That's why if Lady Ada shows up, she shows up later. It's because she's in a meeting beforehand. I haven't been to Michigan for a while. My partner's family's from Michigan, and I like it. I miss seeing that side of my family. Cat cam has been rearranged. Andrew says, not sure what the deep dives usually cover, but I'm trying to learn how to do tightly timed things like MIDI sync out using CircuitPython. What frequency of MIDI sync out do you need? And is it out of UART or USB or BLE? I think generally for audio things, except for the actual sample playback, CircuitPython is kind of well within the tolerance. Keith E says, where in the doc do I drop questions? You can put them in the timestamp ones, or you can just post them here, and then folks can move them over too. Hi, DCD. Thanks for joining. Good morning, Unexpected Maker. Yeah, I haven't seen actual comparisons. Generally, for tightly timed things, we use this underlying C stuff. So for like pulse timing, and we can get down to like a microsecond or microsecond-ish timing. I haven't done a whole lot of MIDI stuff, so I'm not sure kind of what the thing is. T minus 2:15 minutes. Oh yeah, I should clap. Clapping is really... DCD, are you ready? I'll clap I'll clap so that we can have a time code to sync up with if we need to. And I know that there's probably a lot. So I'm going to clap in 3, 2, 1. We can use that to sync if we need to. I'm wanting to do USB MIDI out from a Trellis M4. Okay. So I think the MIDI sync should be able to keep up generally with how fast the USB is going. Of course, there's always things from Python, like the challenge with Python and doing timing sensitive stuff is that you, normally in C, I'd set an interval timer and surface it with a sync out message each time it goes off. Yeah, you could certainly do that in Circup Python if you wanted to. Like we have the like lower level MIDI stuff that you could set that up in C. The challenge with Python is generally garbage collection. So if you're doing something that is doing churning memory, like occasionally it'll have to free it and do some administrative stuff. And that's really where you're going to get potentially really long pauses. Hi, Joshua. Keith E says, due to math, MicroPython is looking at adding complex numbers as default D-type, but it comes with a space cost. I was curious what your thoughts are on it, whereas I don't understand enough about the underlying design to know if you could just import microlab complex as an alternative. Yeah, so I don't think so. You could probably do some tricks under the hood to do that. I really don't use microlab myself, so I don't have a good feeling for like what's valuable enough. Certainly in the ports where we have space, I don't see why we couldn't just add it. But like the modularity of NumPy and stuff is not very well defined. Like the fact that D types are kind of like this under the hood thing. So that's kind of, it's just like NumPy is not meant to be modular in this way. So, some more questions. So, will the Raspberry Pi 400 and CyberDeck work with the Hyperpixel 4 square? I don't know, Ryan. Sorry. Joshua Fogelson asks, why is stuff on Adafruit way more expensive than other places? I wouldn't say it's way more expensive, but the point is that you're getting a lot more than just the thing. You're getting Adafruit support, you're getting all the software that I'm paid to write, you're getting like support on the forums, all of the software, all of the tutorials, right? Like it's unfair to compare just the device versus everything you get to the device and everything else, right? Like, and this comes up. We see people posting on the Adafruit forums asking, hey, I have this thing, how do I use it? And it's not an Adafruit product. And we have to tell them, go here. Like, you bought something from this other company. It's not our job to help you get going, right? Like, that is the privilege that you get with Adafruit, is that you get access to support, whether that's both the people or the software. You can use the software on other stuff, of course, but like, we're not going to help you fix it or get it going. And that's actually incredibly valuable. So while the individual unit thing might be more expensive, like the reality is you're getting a lot of your a lot more for your money than that. Hi, Joshua Harwood. Dylan also points out also better testing and quality control of Adafruit products. Yeah, some places won't even test all their stuff, whereas Adafruit tests everything before it ships. And if it happens to get damaged in shipping, like you can reach out to support and they'll either help you fix it or replace it for you. So there's a lot more to it than just the device itself, and sometimes it's hard to recognize that. Okay, let's do some housekeeping. Hi, Johnny. I think if I want a RetroPie setup not portable and I want to sound which Raspberry Pi should I use? If it doesn't matter, I will use a Raspberry Pi Zero W. Yeah, I think so. I haven't done a lot of Raspberry Pi stuff, so maybe other folks in the chat can help. I think a lot of audio goes out the HDMI link. Joshua says, I'm no longer a customer of Adafruit because I can get the same thing way cheaper on Amazon or eBay. If you want to do that, that's fine. But don't go to the Adafruit support forums or this chat and then ask about how to get something working. That's what you get for using Adafruit stuff, is you get folks to help you. That said, like, the Adafruit Discord server has plenty of people that are knowledgeable about things. And a lot of them are helpful and they're not paid by Adafruit, so there are places as well. Renee from Twitter asks, all right, I guess I should get, well, hold on. Sorry. I'll take a pause on questions while I do housekeeping so we can get everything kind of officially kicked off here. And sorry if there's background noise. I have the window open. It's actually like kind of warm and sunny and nice here today, which is great. So, hello everyone. My name is Scott, and I work on CircuitPython for Adafruit. CircuitPython is a really easy to use version of Python designed for microcontrollers, which are inexpensive little. Ooh, I'll show this one. So what we got here is so the microcontroller here is this chip here. It's really tall, inexpensive, or really small, not tall, small, inexpensive. It's a little tiny computer. This one runs at 64 megahertz, I think. And this is a Circuit Playground BlueFruit. It's an all-in-one device. It's got a bunch of NeoPixels and buttons and speaker and microphone and all of that stuff. This runs, I think, $25. So it's a great all-in-one getting started learning electronics. I've been using it for testing some Bluetooth stuff that we can talk about a little bit later. So CircuitPython runs on devices like that. Adafruit is an open source hardware and software company, so that's some of their hardware that they design and sell. So that's how we make money. That's how I get paid. I get paid by Adafruit to work on the software for this hardware. So if you want to support me, you can do that by supporting Adafruit at adafruit.com. Purchase some stuff there. If you want to chat with me and a lot of other stuff, a lot of other people, you can join our Discord server at adafru.it/discord. It's hosted by Adafruit, but we don't mind like people talking about non-Adafruit stuff. The line we kind of draw that we were talking about before housekeeping was just like Adafruit paid people pay to answer questions for people who have bought stuff from Adafruit. So this is a deep dive. It happens every week, normally on Fridays at this time at 2 p.m. Pacific, but occasionally it's shifted to Thursday at 2 p.m. So I'll just try to give heads ups about that. It typically goes for 2 hours or more, so buckle up. It goes a while. I got good sleep last night, so I shouldn't fade out quite as much as I did last week. Questions are always welcome. If I'm in the middle of talking, I'll go back and try to catch all of them. One thing is the cat who's in the corner here, that's Spook. He is epileptic, so if he has a seizure, I'll just be watching him and making sure he's okay. But he's been doing really well, so I don't expect that to actually happen. So that looks like all the housekeeping. Let me say hello to some more folks and answer any more questions that came up, and then we'll keep going. So, yeah, Neradoc says it's also unfair to compare cheap bare devices with a Feather that does battery charging and all of that, for example. Yeah, it's true. Boards are also about like form factor and what are on them. Sorry, let me pull up the Twitch and ban the person who just... I don't know. Just had a spammer on Twitch, so... Oh, I'm not logged in, that's why. This is the joy of moderating while I stream. Sorry, folks. I should have been logged in beforehand. Nobody wants to buy followers, right? Here we go. Block. Sorry about that. And I'm getting echo too. It's pretty quick on Twitch though. It's like right behind me. I think that worked. Anyway, okay, so sorry. Okay, let me look at the YouTube chat. Bruce says here it's a beautiful day around 20°C in the sun. Was just out on my bike. Nice. Yeah, it's beautiful here in Seattle, just south of you. Vita Graph says, I always remember something I need/want right after I place an order. Yeah, what I do is I usually have an open cart of stuff. I'm in a weird spot, right? Because I get stuff for free. But that's kind of how I keep track of it, is I just have always, if I don't need something immediately, I'll drop it in my cart and buy it the next time I make an order. I might make an order for a prototype, for example. Hi, Gladius. Hi, Paul. Joshua says, I'm quite knowledgeable of electronics, so I don't really need the help from Adafruit. That's totally fair. That's totally okay. Yeah, and that's fine. Like, Adafruit knowingly targets the audience of beginners, because the group of people that don't know electronics is vastly larger than the people that do. So it makes sense from pick who our customers, or focus on which customers. And a lot of stuff that we do for the people that are designed for the people that are, a lot of what we do designed for the people that don't know electronics, actually benefits people who do as well. Whether it's just stuff to reference or code to start with, things like that. Gareth says, so how's BLE going? Great progress last couple of weeks already. Getting excited. Bruce says, also no people around as we were between seasons. Love being alone without all the road bikes blasting past me. Mark says, or you can be like me and forget you dropped an item in your cart, and next time you order, put it in again and order two. Awesome. Well, thank you to everybody who does order. As I said, this supports me and a bunch of other folks that Adafruit pay to make all of this open source hardware and software. Okay, so Gareth's asking about BLE, but I just want to touch on a couple other things before we get to the BLE stuff. Gareth, let me know if you can't stay for the whole 2 hours and I'll reorder, but I do want to talk about a couple things first. So let me switch to the desktop. And spoilers, it's in the notes doc. So first off, I wanted to point out the project bundle. And I could 1825 is the time code here. Yeah, so if you go and learn, what we added, and I wasn't directly involved in this, so other people deserve the credit for here. Gareth is here for the duration, fully buckled. Awesome. Well, thank you. So Project Bundle is really exciting. It's something that other folks have been working on. I haven't been working directly on it. But the idea is that you can go to a Learn Guide and you can just download a zip file of all the files that you need to run the whole project. So if I click here and open the Learn Guide, we can see the parts I need. And then I think what we need to do is we need to go here to the software part. And then, oh, I love it when pictures load late. That's the best. So here's how to get started with CircuitPython. And let's see, where is it? If we just skip to the code, you can see now there's this nice big button that says download project bundle. And what this does is it downloads a zip file. So I'll click that and it has the zip file, and I'll just open it here and we can see what's in it. So this here, you can see there's a code.py, a readme, and then in the library, there's just the libraries that you need for the code.py. Now this is super, super cool. this has been a long time coming. Like, we haven't had a great story about, oh, you can see the plant better in this view too. We actually hung some plants up here. So this has been a long time coming, from when we first started doing the like library bundles that just have like a ton of everything. And the problem is that they like no longer fit. And then like once we had Blinka, we had reason to like maintain dependency information between all of the libraries so that if you pip installed something, you'd be able to say like, oh, I need this and this. And so what this project bundle stuff is doing that like Melissa did some of the work, Justin did some of the work, and I'm sure I'm forgetting folks. So sorry for the folks that I'm forgetting. So what it basically does is it starts from example code and it figures out all the libraries that are imported. And then once it knows those libraries, it can bundle those libraries plus all of the other things, plus all of their dependencies as well. And then there's also like it also includes non-code files as well. So if there's any fonts or images that are in the Learn Guide repo for that Learn Guide, those will be included as well. So it's really meant to be just this like download a zip, copy all the files over, and it just works sort of thing. And we're very excited about it. I know we're going to talk about BLE a little bit later, and Gareth was talking about this, but one of the things that I would like to see is a Bluetooth app where with like a Circuit Playground that I was showing earlier, what you'd be able to do is just open this app on your phone and then pick a project, transfer them all over, and it would just work. Like straight out of the box would be really cool. So that's the first thing, the project bundle. And I think we're very excited. Unexpected Maker says that's very cool. So kind of what we're expecting is like we're seeing this in Learn, but we're also expecting to see it in like a couple other places. Like there's the Circup tool that Ask Patrick W has been doing some work on, and some other folks as well. So Circup's been great. Circup is a command line utility that allows you to just say Circup and it will update all the libraries that you have on your board. That's really convenient, and it's using a lot of the same information that the project bundle is. And then I think Melissa's also been looking at integrating Circup and like this project bundle stuff into editors like VS Code as well. So there's going to be some really cool things coming down the pike with this now that we kind of realized we had that data and like have cleaned it up in the places we needed to. So this is just going to be good. Neradoc says Circup is amazing. And Johnny's in the Discord too. Awesome. Okay, so that's Project Bundle. If you use Learn Guides and do that, this should get you going even faster, which is really cool. The next thing I want to point out is we hit another milestone. Last week we talked about 1 year of deep dives. CircuitPython is kind of geared towards board to board things. So if you go to circuitpython.org/downloads, what you can do is you can find all the boards that kind of work, quote, out of the box. And so this is a really neat page here, and there's lots and lots of stuff there. It's sorted by popularity, so you can get down into these like not like brand new boards that aren't like fully released yet, or this like Game Boy thing that I made that nobody has a copy of and I don't even use. And this one's a new one as well. So we crossed the benchmark of 200, or we're directly at 200, which is quite incredible. It's like for 200 boards that people could purchase, they can just come to the site and they can download CircuitPython for it. And the experience across all of these boards is pretty uniform. Some have displays, some don't have displays, and blah, blah, blah. But all up, like, that's pretty wild. So congrats and thanks to everybody who's added their boards here. So that's cool. And one thing that we've been pointing out too is every time we do a release, we sort this by the number of downloads. DCD says 200 boards. How many different CPUs? That's a good question. I think, ports wise, we have what? SAMD, NRF, ESP32S2. SAMD is really 21 and 51. The RP2040, IMX RT is another. So we're what? Like, Randy says, I have the Game Boy board. I just haven't tested it yet. Yeah. Yeah, I mean to respin it with RP2040. I think that's going to be better than the SAMD 51. Renee says, I'm really happy for CircuitPython for the novice and young programmers intro. Yeah, STM, thank you, Neradoc. Speaking of Neradoc, there's this other cool thing that they just added, since we're talking about cool stuff. I don't know. Over Feather S2 is number 12. Nice. Yeah, I've been wanting us to publish download numbers every day, but we've been switching it up how it's done, so maybe we should do that. All the download numbers come. We host all the downloads on S3, which is the Amazon Web Services like file hosting thing. So we have numbers for that. Where is the Neradoc? Where is the filter thing? Gee whiz says, so how many of them will be available over the next few months? # chip shortage. That's a great question. I think time will tell. I know that Lamore has said that like the mainstay, like the Circuit Playground Express, not this one, but the other one, like they order in large quantity, so they have a good backlog. Is at the top modules, core modules. Ah, there you go. Perfect. So I think we're very happy as Adafruit that we have a variety of chips that we support because the chip shortage is hitting different people in different ways. So we're feeling pretty good in general that that we're going to have some products in stock still. And then the other thing is that it's a really good time for us to focus on the software side. It's giving us a chance. Like Dan's doing a lot of really cool work for USB that maybe we should have Dan back on in the next couple weeks to talk about when he has a PR out. But he's doing like being able to change the USB descriptor in boot.py. So if you want to like have a specific HID descriptor for a particular reason, or you don't want to turn the storage on or all that stuff, we'll be able to do from boot.py, which will be cool. And then I'm working on the BLE side of things. So it's a good time for us to not really. Jeff is working on the IMX RT. So we are doing some kind of platform specific stuff. But generally we're kind of focusing on like building out our software and our workflow and our experience stuff right now. Gareth says +1 for Dan. Ryan G says, any plans for the NRF53? Looks like it would need Zephyr due to being only supported in NRF Connect SDK. I haven't looked at the NRF53. Let's see what it is. Third generation. Oh, interesting. NRF 53840. I haven't been watching what they're doing. It's 2 Cortex M33 processors. Hi, Daniel. Hi, Hugo. I would say we don't have any immediate plans. I think it's really cool that there's a network core and an application core. And 512 kilobytes low leakage RAM. I think cost is the other thing to consider. But I don't know if Lamore has been looking at this or not. I think once we have Bluetooth stuff, it would be worth looking at. Yeah, DCD. That's the link except for EN latest, not 62X. Keith E says the changes and improvements to the software of late has been a delight to watch. I'm really excited to see the code ecosystem mature even further. Yeah, me too. This is actually a really interesting time in CircuitPython land because of we just tagged 6.2 stable. So 6.2.0 is out. It's stable, and we've kind of designated that the main branch is now 7.0. So it gives us a window of opportunity to do some like more dramatic things. And I actually have something in mind that I was meaning to do. Bruce S says the NRF 5340 doesn't look that pricey. I should see if I have one. Yeah, I'd be curious. But again, like talking about the chip shortage, like it's gonna depend on like whether we have like whether we could get chips or not would be interesting too. BTET says any obfuscation techniques if you want to make Python code unreadable / hard to read or protected from prying eyes. Generally, like no. Like the MPY config is like a bytecode version. MPY version is like a bytecode version, but all the strings are the same still. You might be better off trying to just secure it if you want security. Like turn the mass storage off, and then you could do things like flash chips sometimes have the ability of like scrambling the data between the flash chip and the device itself, so that even if you're like plugging onto the flash chip, you can't read what it's reading. But security is not something I've done a whole lot of. So yeah, generally it's not something that we think about. Okay, what I was going to talk about that Neradoc did is this support matrix. It's on the CircuitPython read the docs, but you can filter the boards by what they have. So if you want to know what boards have like alarm, which is for the deep sleep stuff, you can just type in alarm and it will tell you the 19 out of 207 boards that we have that have that in there. What is a good example that we only have limited? Like maybe, I think you could do 2 as well. You can say what have alarm and terminal IO, which is all the display IO stuff. Daniel says, wouldn't the 1 megabyte flash in the NRF53 limit the core modules available in the CircuitPython build? Yes, potentially. We'd probably have a second. We would probably still have an external flash because 1 megabyte flash is pretty tight. So if we had external flash for the file system, 1 megabyte flash is actually quite large for the core itself. Of course, with Bluetooth, we would share that with the Bluetooth stack. But we would probably just have like, external flashes are kind of like 2 megabytes at the minimum. 2 megabytes to 16 megabytes is typically what you see and what we use in our boards. So like, we probably wouldn't put the file system internally. We would probably just have it externally. Yeah, so this is really cool. Thanks to Neradoc. Neradoc's been just doing some really cool stuff. Some improvements also to like the CircuitPython downloads page as well. I think you can now, if you filter by like Bluetooth, I think, yeah, it goes up into the bar too. I think Neradoc fixed that as well. So really cool stuff. Thank you to everybody who contributes to CircuitPython and circuitpython.org and stuff. Okay, so how are we doing on our list? First, before we get to Bluetooth, I wanted to talk about GitHub Actions. This is something I did earlier in the week. Talking about support. Support can be a real challenge. We have like 1,500 GitHub repositories under the Adafruit thing. Oh, and that reminds me, I also didn't talk about, did I talk about this? So this github.com/Adafruit is kind of all the stuff that we as Adafruit want to, then the NRF53 network core has its own flash and RAM too. That's awesome. Yeah, I think it would be cool to support the NR53, but it's not high on my list. So let's see, where's the count? Yeah, like 1,500 or so. So these are all the things that we support. And it's important to say, like, it's important to us for it to well-define things that we as Adafruit, the company, want to support or not. Renee, I see your question. Sorry, I'll get to it in just a bit after I finish this thought. So one thing we're doing, one thing I did, this is the thing I thought of when I thought of this, is we actually have github.com/CircuitPython. And we've started to use this. We now have like some people added from the community as well. And we have a team for the graphics stuff that folks have been doing. So this is something I'm really excited to grow. I'm excited to grow the stuff that we as a CircuitPython community support separate from what Adafruit supports. So this is going to be really cool. It's just the early start, but like I've always said that I want CircuitPython to be bigger than Adafruit. And so I think we started to see like groups of people, teams of people working on shared stuff. And so by having github.com/CircuitPython as the place for like the CircuitPython community supported stuff to live, I'm super excited about that. So I think that would be really cool. Gareth says RISC-V for the next CircuitPython chip. So we have RISC-V support already with the FPGA stuff that somebody merged in. The CPU cores are not that interesting because the compilers just support them. But I kind of expect that we would probably support the ESP32C series as well. Once we have a BLE workflow that we can use, because it doesn't have native USB. So let me get to Renee's question before I forget. So Renee said, do you by any chance have tested TinyML in CircuitPython? So we haven't. I'm aware that there is like a TinyML for micropython, I believe. I thought I saw that somewhere, but I'm not sure. Maybe I was making that up. It's something that we're thinking about. One thing, when we knew that was coming for the RP2040, so when we picked how much of the external flash to set aside for CircuitPython proper, we actually left a lot of space, hoping that that would be enough space to fit TinyML on the RP2040. So it is something we're thinking about for sure. And I'm not working on it personally, but Hierophect, Lucian, who works on CircuitPython for Adafruit, is wrapping up some awesome low power stuff for the NRF. He's doing the review for the NRF52 low power, and he's doing the low power for the RB2040, and did it for the STM as well. So once he wraps that stuff up, I think he's going to take a look at whatever work there is for TinyML from CircuitPython. Renee says, perfect, with stars in their eyes. Minnesota asks, how do you keep mindful of need to update the time log? I think I need a timer or something. Yeah, David usually does it. DCD in the Discord chat is awesome and does most of the time codes. I think they're based on the time codes on YouTube, but I'm not positive. But yeah, thanks to David, as always, for doing that. Okay, so the other thing with popping off the context stack. Yeah, Minnesota says, so very useful in later review. Yeah, the time codes are great. Thanks again, David, for doing that. So the other thing is that it's pretty common with CircuitPython libraries. We have this continuous integration tests. These are automated tests that run whenever somebody proposes a change. And we found that it's like the output of those and finding the problems is quite difficult. So I did some work the first couple days of this week to make that easier. One thing I did is, and this is Lady Ada's idea. So if you make a pull request, this hasn't rolled out, I don't think yet. But the idea is that when you make a pull request to a CircuitPython library and it fails the workflow, you'll get this message from GitHub Actions bot that says, Gareth says less of a stack, more of a pile. Yeah, I like my piles. I have a pile on my floor right now, so yeah. So GitHub Actions bot will post this thing with some helpful links to say like, hey, it looks like test failed, point you to where they failed. And it will also point you to the Learn guide for doing pre-commit and syncs, and also to the Adafruit Discord for help. So that was kind of like Lady Ada was replying to a lot of people with that info. So she was like, can we automate this? So that's one thing we automated. And the way it's done is it's actually a GitHub action itself. So you can see like, oh, publish this action to the marketplace. But what you have to do is you do have to change the workflow for each individual repository to just use that action. And what it does is it actually, so one of the challenges is if, say you have multiple workflows fail, you don't want to post multiple times. So the question is like, how do you do that? The way that I implemented it is from the bot, we mark it with the eyes thing that the bot is looking at the pull request. And when you do that from the API, it will tell you whether the reaction existed or not. It will tell you like, yeah, I created it, or it's okay. It already existed. So what the bot does is it actually sets the reaction, sees if it existed or not, and if it was created, if it didn't exist, then it posts the message. All the other times it won't post the message. So that's one. And then, so the other, Han, I'll get to your question. I'll get to questions after I finish this thought. So the other action that I made is, this is called the CI problem matchers thing. And what you can actually do from GitHub Actions is you can set some regular expressions that basically match lines of your log file. And they highlight them in red, but also they like end up showing them in different places, which is like super duper handy. So here you can see this is like GitHub Inception. It's because it's pictures of my GitHub in a GitHub page. So the first thing you can do is on the summary of the workflow, you'll now get a list of annotations, and this pulls out like you don't have much control about what these messages are. That's why they're kind of like not helpful. But at least they're highlighted here before they weren't at all. But then it gets more helpful when you look at the log output. So you can see here that like the individual lines are highlighted now that match the problem matchers. So it highlights all of the it highlights what Black reformatted. It highlights all of the pre-commits that failed. And it will also pick out pilants that fail. And when pilant fails, Pilot will give you the file name, the line number, the column, and the message. So those actually end up in the file view. So this last screenshot I have is on the file view of my test, where if Black reformats it, it tells you the file, so it ends up at the top of the file. And then if there's a line number associated with it as well, it'll put it in the file. So that now we have a thing that says like, oh, it looks like it failed. Here's a link to where you can see how it failed, but here's also help to do it. And then this work will bubble up and make it more obvious what things failed on the library itself. So I'm pretty excited about this. Hopefully it won't confuse people. Hopefully it'll help them. And I actually do have a third pull request that does this problem matcher thing, but on the core, so that the core will highlight what boards and language combinations failed. Hackaday has a new stream called The Deep Dive. They should have me on it. David says timecodes are synced to the PC clock and then adjusted as needed. That works. Okay. So those are the things, and hopefully Dylan's going to help roll those out. He's going to roll those out. So that'll be super helpful. I'll do questions. So Han asked, I've tried to install MicroPython on the RP2040 Feather, but I was unsuccessful. Which file do I need? Found one broken link on the Adafruit site. I know they merged it, but I don't know if they've released it yet. if we look at pull requests, you might need to build it yourself. I don't know if they have nightlies. Make for different boards. But that wasn't merged. Yeah, it might need to be made yourself. I haven't actually looked at this. I should. You can see there is an Adafruit feather RP2040 definition, but I don't think it's on the, like, MicroPython has some of the board listings if you go to their downloads, but I don't think they have everything. And then I don't know what we have on the product page. Generally, we hope people would use CircuitPython. But I think you're right in that we did put a MicroPython link. Right. This is a little out of date because I think they released the Arduino core. So yeah, they got rid of, Raspberry Pi got rid of their MicroPython fork completely. It's just an upstream MicroPython. But we don't have pre-built stuff. If you want to help me out, I can't edit these myself. So what I would suggest is email support and let them know that that link doesn't work, and they'll figure out what to put there. They'll at least edit this so it doesn't say that. I think that there's also the getting started with RP2040 site. I know that there are some MicroPython links here as well, and like they're highlighting that there's multiple boards. I don't know what they're... That's, I think, for the Pico only. If you want to try CircuitPython, what you do is you go to circuitpython.org/downloads, and then the feather RP2040, and then just hit download. You need a .uf2 file that will go on the rpi-rp2. I'm biased, but I think this is a great way to find how to download CircuitPython. Gareth says, I love the bot, but I would add a sentence to say that if you need help from a human, come on Discord. Yeah, if you want to change it, propose a change, the CircuitPython action library failed. This one. Oh, I thought that was right. You can make a PR. I'll show you where the text is. Action CI failed, and then it's in this index.js. And you can see the text for the body of the message was right here. So if you have thoughts about it, go ahead and post those there. Hans says, CircuitPython is working for me. Gareth, I'm a kind of purist just to see if I'm able to get it to work. Yeah, I think you might need to build it yourself, unfortunately. Oh, Yuri has a deep dive on Raspberry Pi Pico and RP2040. I'll have to watch that. Okay, so we've been answering questions. It's like pretty warm in here. It's one of those things where I probably shouldn't have had the window open while it was hot outside. It's like I learn it every year. File transfer protocol stuff. Yeah, let's talk Bluetooth, shall we? Let's just show. So the place to follow for this is, or if people don't know, let me take a step back. I've for years wanted, because we produced this, the Circuit Playground BlueFruit is like a year or two old now. And And what I wanted at the time we were working on this, and I still want, is I want to be able to use a phone or a tablet, which I have over there, to program Bluetooth devices over Bluetooth. And I've been really gung-ho about this idea for a long time because I know how many people start the first computers that they own that are theirs are not, they're not desktop computers, they're not laptops, but they're phones or tablets. And so as, you know, working for Adafruit and really trying to aim for the people that don't know electronics yet, being able to open programming and electronics to people who don't have like computers with keyboards, like physical keyboards, is like incredibly important. So I wanted to do it for a long time, but I've just like finally, once I got all the RP2040 stuff done, had the cycles and the focus to work on it. So one of the core pieces of that is being able to transfer file contents across over BLE. And so this is kind of like, somebody pointed me to rsync and I forgot to look at rsync. But there's also like FTP, like very basic, like list a directory, delete a file, write some stuff. So I've made this library called Adafruit CircuitPython BLE File Transfer. And this is where we're experimenting with the protocol to transfer things from one device to another. And I've had this open pull request where I've been working on it, and I need to fix that. It's still, I was hoping it would be fixed. So Trevor, I'm working with Trevor. He is doing the application side. So he's an iOS dev that I work with. So I've been doing all the meetings with him as well. He's working on this app called PyLeap, which is totally subject to change. And we are, the goal is kind of like the bundle stuff of just shuttling files over. But then we may also want to have ways of like editing the files that are on the device. Minnesota Mentat says, how much data, how frequently? So I think it's assumed for me that like if you're iterating on a code.py, you're talking a few kilobytes at the most, relatively frequently. But if you're like loading a bunch of stuff on it, might be a lot more data kind of like once. So I'll show you what we have. So there's this pull request. So if you have thoughts, Unexpected Maker says, got it any faster than 10 kilobytes per second or yet? I did manage to see some numbers of that, but the numbers I'm getting right now are actually a little bit lower than that. I'll get the demo going because I had it going earlier, so I should be able to, I'll show you what I got. So I do have the overhead here as well. So let me just, I think I can maybe fit it all under the overhead. I can at least do this. So this is my mouse trackball hand. But I've got this USB cable and this feather. Neradoc says, wait, accessible to people without a PC? It's too easy. You're making it too easy. That's what I do. That's my job. My job is to make it, and nothing's ever too easy. There's always problems. Okay, so I'm plugging this side in. And I'll just, let's see, I have this. So they are right next to each other. So some of the speed stuff is probably subject to change as things. So that's all I did. I already had code on here. And then let me pull up the terminal. And I use TIO, which has been really nice. So I just do TIO to 1. And I think I could pop out a second one. TIO to the other. It's possible that they're not named. Right. So if you ever do connect to a CircuitPython and it doesn't do anything, and this is actually, no, it gave me a dot. My keyboard shows up as serial as well. So this is the one I don't want to talk to you. And in fact, let's just list. Oh, you know what? I do have a switch on this, so it's possible that if I turn this switch on, ACM1 is now connected. So I think TO0 and TO1 are these devices, hopefully. There we go. So the one inset is the one that's acting as the client. It's the thing that's like writing to the other device different files. And it's doing a series of writes and reads and listing a directory. That's what this is. And it's writing other stuff to files. And it's just doing that every 20 seconds. And you can see the rates that I'm getting right now are, I'm getting about 5.5 kilobytes per second writing and about 6 reading. But if I do, let's see, if I pull this up, so it's the feather doing the writing. So you can see I have 2 removable drives, and I renamed the it's usually CircuitPy is what it shows up as, but I have a boot.py that renames it to keep them straightened out. So if I open code.py here, here's what you'll see. This is all the demo code here. And what I'm doing for that kind of like larger file speed test is just, oh, I didn't know there was a sleep in there. I had a bug that needed that. Let's see if that changes the number at all. Yeah, so it's about 5 or 6. Hi, Dave. So it's about 5, but this is only a 1K file. I actually played around with this a little bit yesterday or the day before. And let me switch over to desktop. You don't need to see the boards. They're not doing anything interesting, at least right now. So I changed this number from 1024 to 4000, and I'm going to hit save again. And then we'll see that this auto-reloaded. This is how CircuitPython works. You hit save, and it restarts the code for you. You can see it's connecting. And there the write speed there is just over 11K bytes per second. So I'm pretty happy with that. And that's 7 the other direction. So, you know, if our file is like under that, Gareth says, so wait, did you get a 2x speed up from last week? Somewhat. So some of the speed ups that I got were because of the protocols designed for the server, which is the thing that's storing the file. The server dictates kind of the rate that the data is transferred. And so that changing that number about how big the chunks are before you before you communicate again can change the rate. And then there was an error with reading where like CircuitPython had some problems where if in Bluetooth terms, the writing is done via a write no response command or whatever over Bluetooth, which means that like it gets written to the other device. It's reliable, but there's no like confirmation that the application code got it like sent back, which means that you can send repeated write no responses much faster than if you're waiting for the round trip again. And then the other direction, if it's a read, it's like a series of notifies, which is kind of like the reverse of write no response. It's like notify, but I don't care if they actually heard. And notify has some weird constraints as well about like how big the packets can be. And I've been finding CircuitPython bugs amongst a lot of this stuff. So the version that's running on these devices is actually like, I have a PR out for some fixes for it. Minnesota Mentat asks, have you tested the upper limits? I'm not sure what you mean by upper limits. All my testing is pretty basic. I try not to get too wrapped up into all the details of things. There's certainly more speedups we can do, and I'm okay leaving those on the table. One of them could be like, there is actually Bluetooth 5 has a 2 megabit per second transfer rate instead of the 1. Minnesota says, speaking of sustained speed for larger files. I mean, we could see, like, we can raise this number even higher and just see how it changes. It's writing just to... So the other thing that this isn't taking into consideration is it's not taking into consideration the flash write speed, because on the server side of this, it's just going into memory. So we got a little bit more of a speed boost here. I think some of it's going to vary a little bit with how well your data kind of fits into the packets. Like if you're doing like 1,000, or I think right now it's set to do 4,000 size chunks. If we just go to the Circuit playground and look at like the other side of this, you can see there's this chunk size parameter. So if I turn this down and just do like 100 bytes at a time, that's going to really slow us down, because like Bluetooth itself can do larger individual packets. And it's possible I'm going to break it too. It's like generally pretty resilient, except when it crashes like this. So this is just with that like 100 chunk rate, which is and maybe it's broken. Oh, it's just slow. I think it's working. It's just slow. Gareth says it looks like really good speeds. Even a bundle with some audio video assets would be tolerable. Yeah, I think like the most data you could ever want to send is kind of like the limits of the flash size, right? So 16 megabytes are about like the upper limit of what you'd ever transfer kind of in one go. And yeah, it would probably take a few minutes at this rate, but ideally it's just once, right? Like I'm more concerned about the like how fast is it to iterate than it is to like dump the bulk stuff over. So it's interesting to it's important to remember like you can always iterate on stuff later. So here you can see our write speed is actually only was only like 1,100 bytes per second, and 8,000 back, which is makes sense because chunk size is dictating how fast you can write to something. The chunk size coming out is still large. So yeah, this chunk size is basically going to end up, I think, the size of like the file system writes, right? Like it's probably going to be 512, or like this chunk size is meant to allow you to have like a limited buffer that you're doing internally. So it might be like 1,000 or 2,000 or something. But yeah. As Patrick W says, did you talk about how CircuitPython gets onto these devices that are BLE only? Will that be a per chip manufacturing process? That is a great question. That is something we're going to need to solve. I believe the bootloader on the NRF52 boards we sell does have a Bluetooth mode, but I haven't looked into it. So I think it's a great question, Patrick, and it's one of the things that we'll have to figure out. Alvaro says, you need a dev null for CircuitPython so you can bench the wireless speed only. I mean, that's basically what this is. It's just storing the data in memory. But I think it's pretty likely that these numbers will increase just after I implement it in C as well. Because Python is a bit slow. And the Python that I wrote is definitely not optimized either. Like it's doing struct packs, which are doing allocations and things like that. So it's the Python version of everything that I'm doing here. It's really geared towards being kind of a test bench of the protocol, not to be like the end all be all best implementation of it. It's meant to be like I was trying to unlock like Trevor working on the app side, for example. And shout out to David Glaude, who pointed me to Pete Warden, I think it's the guy's name, who does like TinyML for Google, and he like just created his own BLE file transfer protocol as well. So I'm hoping that the timing of this is right, and we'll see a lot of adoption. One thing I did do, and maybe this slowed it down a little bit, and folks can tell me if this is a good idea or not, but the change I just made is actually to add padding. So I actually added like empty bytes to some of this stuff, so that like it's usually like byte and then something, and then like 4-byte integers, like larger numbers. And I wanted to make sure, I was like, you know what, thinking ahead to when I'm implementing it in C, it'd make it a lot simpler if I got a packet, the like 4-byte values were all aligned to 4 bytes, so that I can basically just cast it to a uint32 array and then just read the values out. And so I just today, I tried to ask Dan, and Dan missed my message, so he didn't get back to me. But I was like, you know, it's probably worth the like a little bit of extra overhead to just have that be convenient. So if you look in the latest change of this protocol, like you'll see that I'm adding these X's into struct pack, and those are padding bytes. So struct is awesome if you haven't done a lot of Python, and particularly it's really good for Python and embedded. Struct is just really handy for going from Python objects and numbers down to a byte string. So Struct is really good for that. Unfortunately, I did find a bug in Struct today, so I found and fixed that. So there's a PR out there for fixing struct pack, which was broken, slightly broken. So yeah, I think in my book, this is kind of where I want the V1 version of this protocol to be. I should also point out one piece of feedback that Dan gave was it would be good to have offsets. So it's a way to kind of like make sure that you stay in sync as things get transferred over. So there are now offsets that are sent. So if you're reading data back every time you do a chunk size, you'll get a header, and that header will have the offset of the data going forwards. And then what he said also is like, that would make it really easy to put an offset in the command itself. So we actually have offset in the commands now, which means that you'll be able to write starting at a particular location of the file, which means you can append. So you'll be able to append, and you'll be able to like write the latter part of a file potentially. You won't be able to like write just a bit of it. Like maybe you could do that. I'll have to figure that out. But then you can also read parts of you can read a suffix of the file if you wanted to. Yeah, Minnesota meant that. Hear you regarding Struct. Yeah, Struct is great. All right, so that's where we are. I think I'm definitely done with this for the week. The next big thing for me is I think I've gotten all the feedback I expect. So I think next week will be about getting that working in CircuitPython core, which will be very exciting because that will start to allow us to actually write to the actual drive. And then Trevor is working on the app side, and he got the app connecting to my tests code, that what I'm running in this test as well. So on his side, he should be starting to implement the file transfer protocol as it's laid out here, but on the iOS side. So we'll have an app to test maybe in a week or two that can read and write files either to this fake stub or whenever I get the core stuff working to the actual file system, which would be really cool. And I should have brought the fan in here. I'm glad I'm in shorts. Okay, so that's any other BLE questions? I do have one last thing that I want to do. which I thought would be a good, it's a small work item that I think I can do for during the stream. I do have a number of pull requests open that I've got to check back with. Oh, this one failed. Ugh. Oh, thank you, AJ. Let's just try that. How nice of them to fix my test. That's weird that it, the pre-commit worked okay. That's so nice of them to fix it. Okay, so I don't see any questions. I think I bored you all. The last thing I thought, this is a thing I was thinking about doing, and it came up in some of the support stuff recently, but let me go back to the overhead and show you what I'm talking about. So I'm going to eject the circuit playground because we're not going to use that. We're going to move on. Overhead. So here's the feather. And you can see the NeoPixel here is green. It's kind of hard to see. And maybe let me go get acrylic because I'm going to talk about this LED. I wonder if this bag does the same thing. No, that doesn't really help. Let me go get LED acrylic. I'll be right back. So what I have here is just it's this LED acrylic from the shop that really nicely diffuses the LED. So all I want to do here is put that on top, and I'll even zoom in. So I want to talk about what this LED does. That's what I'm talking about. And sorry if there's cat hair. Perfect. So this is the RGB status LED. And ages ago in CircuitPython land, I had this idea of Todd that says you need a laser cutter so you can cut the acrylic smaller. Yeah, I don't have the space for a laser cutter. Nor do I have the patience of tuning mechanical things. I had a 3D printer for a while and it did not work out. Andy Robert says, always out of stock, that acrylic. I think you can get it from Tap Plastics as well. They might have it. Seattle Makerspace has one. Yeah. I don't do mechanical things. Do you not understand that? I will use a giant piece for a tiny thing. Okay, so I think this is good because now I can put it off to the side and we can watch it blink. And maybe I even... which it's hard to tell which way is what. There. Beta Graph says, I don't have the exhaust for a laser cutter. Yeah. Mechanical, what about your Christmas projects? PCB design is about as far as I get. You're right. Okay, so we have just the feather plugged in. And if we... This is the feather. So here's what happened is I control seed and now it's doing this blinking. Has anyone, CircuitPython has done this for years. Does anybody know off the top of their head what this blinking means? My theory is that the answer is no. I've seen people when I've been doing support say, oh, it's doing this particular blink pattern. Can you help me diagnose what's going on? And it's always no, no, I can't. This doesn't give me enough information to really... GWiz says, for BLE, is Android on your roadmap? I think yes. We're going to do it with iOS first, but I think our intention is to do an Android app as well. I know that Foamy Guy, who's done Android development as well, is really interested in it. Yeah, I think Android is going to be that. So I think the line number it's blinking the line number. So it's like exception type, which file it was, what exception type, and then the line number. And it's actually line 250. But I'm not sure. I'm not sure it's right. I just counted it and I don't. Anyway, I don't think it's useful. The response whenever I see this on the support forum is that people should just connect to the serial, right? Like the serial link is what we're seeing here, which is actually telling us what the exception was. So that's not very useful. It takes a lot of code. It's like not simple to like keep track of the flashing. And then if I restart, we'll see that it's green. So green, solid green right now means that somebody just linked to React Native BLE. Yeah, so Keith E says, "Oh, I suddenly want to try using OpenCV to decode it." How is this not known? Why hidden? So we do have a page. We do have a page to help you decode it. We wrote something up, but the reality is that like it's just too hard. I added this before we had like if you have a screen, it shows up on the screen, and also when the code is running, the LED is on, and so when we were doing low power stuff, I realized this LED is a problem. This LED is a problem for low power, and it's a problem for, and the blinking pattern is a problem for what do you do if you're on a battery and your code crashes. So I think what I would like to do, and tell me if somebody thinks this is a really bad idea, but I think what I'm going to do is I want to change the way the LED works when CircuitPython is running. And like I said earlier, 7.0 is a perfect time to do this. Those major milestones, that like top number, that like leftmost number, is all about conveying to people that some things have changed. And so you may need to change your code. You may need to change your understanding of the workflow in this case. So I do have, there is an issue actually open for it. And it might be labeled, we had this label, oh, not bug. We had this label breaks API, which I don't know if I marked it as such. Ooh, so this we should do. Maybe I should do this too. So breaks API is how we designate these are the things that would cause people to potentially have to change their code. Yeah. Minnesota, my point is with the blinking that, like, even though we tell people, they don't really know. Garrett says, but how about a high-frequency flicker that can be decoded with a mobile app to print out error codes? Just, if you're going to do it with a mobile thing, then just do Bluetooth. I don't think the LED is the right way to go. And let's try to find that. We just look at LED. NeoPixel LEDs remain lit up from code when entering the REPL. That's something separate. I know I marked it as 7.0 because that was kind of the conclusion. Like I was about to do it. And revamp status LED signaling. Andrew says, while playing with my new NeoTrinky, I found out about the blinking because I messed up and it was still doing something. Took a bit to figure out. Yeah, so I think what I want to do, this is what I was thinking about this earlier. So simplify the indications, do not repeat them indefinitely. So part of it's saving power. So I think what I want is actually, if your code is running and doesn't set the NeoPixel, it's off, which could be weird. And then I think what I want to do is, if your code is running, NeoPixel is off unless you're using it. 2, if your code fails, if it failed with an exception, blink a red LED every so often, maybe twice every so often. And then 2, if your code is done and completed successfully, I think that's still a reason to blink, because your code finished, it's not running anymore. And you may want to know that. And in fact, maybe what we should do is, let me just copy all the files over, because I want to back this stuff up again. Or maybe, no, I'll just rename this. BLE test. Yeah, Gareth says, but LED to phone cameras, a decoupled link doesn't depend on pairing, just a thought. I know, but you're not going to be able to fix it anyway. Like, it is interesting to think about, but I don't think the complexity is actually worth it. That's kind of where I've come. So here I just did an empty code.py, which means it'll finish immediately. And now we see that it's breathing, ramping up and down. This LED acrylic is perfect for this. So, and you can see the red flickers. The red flickers are actually file system accesses. I was thinking at the time that it's like really like it's like a USB key. But I really think that, I mean, maybe the file system stuff is okay, but I would worry that, like, it's a red color. I think that could be confusing for people if the way that we convey that an error happened is through red blinking. I wouldn't want file system stuff to be confused by that. So I thought what I would do in the next, like, 45 minutes, and what I thought would be for the stream, is I just want to delete all that code. Actually, I wanna strip it out, and I think I wanna do these, like, very much simpler things. Like, imagine it if it blinks red twice every 5 seconds, or something. Like, how far apart does it need to blink for you to realize that, like, something bad happened, right? That's all the blinking I think should be, is just like an error happened, and then you have to level up. You either have to connect to the serial over USB, or in the future Bluetooth BLE. Nerdog says, I wonder if it would be interesting to have a remember the last exception that happened when it is not connected to USB feature somehow, because it's often an issue debugging things along running device or that happen on battery. Maybe through a special file similar to boot.out. Yeah, totally. The other thing is, there's a pending PR, I think, that Christian Walters started. He was doing switching the file that runs after code.py. Nerdog says it's not even Morse code, delete all that. No, it's not Morse code. I wanted something that was simpler. Kristen Walter also has a thing that stores the text of the exception and hands it off to the file. Like, you can say, like, on air, run this other file next, and he did some code that stores the text of the exception that stopped the last file, and is going to hand it off to the new one. So there's some work for that already, and I think that's kind of like the right direction to go. Todd Butt says all new CircuitPython boards have a hardwired klaxon that always plays unless something is wrong. Yes, Gareth points out, is it important to consider people who don't have full color vision, maybe make the blink rates unique for each color? 100%. Yeah. For one, Dan has doesn't have full color vision, so he'll find it real quick. And then also, if we don't actually depend on the color alone, we can actually apply that to boards that only have single LEDs as well. So yeah, I think that's the right way to go. All right, let's get a new branch started and just delete some stuff and see where we end up. So I'm gonna move, I don't know how to move this back in. We'll just leave that over there. Although maybe I might actually just want to jlink it. It might be faster to iterate. It certainly will be faster to iterate if I jlink it. Okay, so I'm not going to use this plug because this plug doesn't have a disable enable on it. So I'm going to plug the jlink in, and this is why the regular feather NRF 52840 is great, because it has that. And then this USB plug that I've got is on a switch. So I'm just gonna, oh, and I should show that too. Did you see that? So if I unplug it, let's see if I can do can I do the acrylic? Oh, you know what? I can unplug it from the other side. Let me do that. So the other thing I want to show is that the LED does do stuff when it starts up, and I think I do want to leave that. And that will be like, you do want to be able to tell people that like, yeah, it's working. So if I just watch what it does when it starts up. So I unplug the other end, and now I plug it in. It should be, yeah, so it's red, yellow, and then the other stuff. So the yellow bit is, if you press it then, that's when you can get into safe mode. And so I do still want to do that. I do want to have like these durations at the start that on power up, specifically power on reset is what it's called. I do want to have times that are like safe mode, and then for BLE, I want it to have a chance to, you can kick it into like pairing mode as well that way. Can it say okay in Morse when it boots? It could, but part of the nice thing about deleting code is that it could potentially also save some code space. Okay, so I'm going to jlink to it. That's going to make it really easy to iterate. So this is the first step, is running the jlink GDB server. And then I'm actually going to switch fetch Adafruit. Get my SSH key going. I always restart before the stream. So now I can do git switch, and then I just found this. Oh, I'm gonna have to update. It's asking me to update my jlink firmware. Yeah, let's do that. If this breaks my jlink, then that's gonna be sad, but. So we'll do that. Oh, and it disappeared. So this is a syntax for starting a new branch, which I just learned today. So I'm going to call it simplify status LED. So we have a new branch. It's based on the latest code. And I'm going to make the feather. But first I'm going to clean, because I switched branches. I hate how jlink exe seems to be so much more interrupty than it used to be. Yeah, even though I'm using the command line, it still decides to pop stuff up, which I don't understand. Oh, and I need to have my Python. So we'll blast through this. Yeah, it didn't used to pop up that loading bar. Okay, so there's the build stuff. Let's find this code. So it's in, this is like my everything project. So it's in supervisor shared RGB LED status. And it built, and I'm going to connect the debugger to it, which will make it easy for me to iterate. And we should see that like it stopped fading because the jlink is connected to it. Is there a command line argument to suppress the jlink pop-up? I don't think so. Oh, dash no GUI. Maybe. Oh, you know what? And I didn't do a debug build, so I don't know why it's trying to read symbols. Jlink's going. What's going on? Waiting for a GDB connection. GDB is unhappy. What's that? Kill. LED HF debugging? High frequency debugging? What is it doing? Okay, give it -9. Is that only kill? Here we go. Force quit. Maybe it's because I didn't make it with debug symbols, which I'm okay doing. I love this computer. It compiles so fast. Although it makes my room real hot. Okay, that worked. So for some reason, it really wants the debug symbols. So I have, in my GDB init, I have these shortcuts. And Sager wants to pop up a window. So this is just loading it. Morse code, hello world. Minnesota says, I do enjoy watching your work like an ASMR thing or something. Great. It's like being in an office with me. I am kind of noisy then too. I'm usually noisy because I'm listening to music. Okay, so if we hit C, we'll see that it started up. So this is just high tech for kids. This is just the stock code. So now let's see if we can't find this. Oh, well, we're in this code. So let's just delete some of it. I was like thinking about this going to sleep last night and then. So here's the line numbers, digit sum, safe mode, exception color, found main, pattern start, total exception cycle. I don't think we need any of this stuff. Make -J32. I hope it compiles fast. Indeed. Oh yeah, sorry about the birds. The crows like to sit out there. Okay. LED status init. Oh, maybe it's not in this. New status color. So I do want all this status stuff still. It's the animation that I want to change. Okay, yeah. So prep status animation. Pattern start. We may want found main. Total exception style. So basically, we do want okay, but all of this specific stuff, like see we have all these colors for different types of errors. I don't want to do any of that. David says, sorry I'm late. Was with a friend, long time no see, and gave him my Circup Playground Express so he can discover CircuitPython or make code. Awesome. Thanks, David, for doing that. Kind of reminds me when Netscape used to have the pulsing end logo. All right, well, I deleted all that stuff. Here's the ramp up and down. Otherwise, exception cycle, flash the file color, flash the exception color, and the digits. So we're not going to do any of this. So we do want to do blinks. So I might want to re-engineer how it blinks though, because ideally if we do like blinks 5 seconds apart, we want to sleep in those 5 seconds. Or whatever it turns out to be. So we don't want to ramp. So I don't want to do ramping. And you know what? I think we do want this tick diff. And we do want safe mode. So I think we do want if status okay. And yeah, if status okay, do that. The return of blink. I did this stuff really early on. I think it's been a long time that CircuitPython has done this. Yeah, so I did want to tell you whether it was main or boot, but we're not going to do that. Not going to do that. And all I want is if status is not okay. New status color. Deleting lines. Maybe have several states like error or panic and then associate them with colors and blink rates. That's kind of what we do already, and that's kind of what I'm getting away from, is like we had all of those, like if it's this type of exception, do this color. And it's actually in this file here. But I think like you can see here is like mapping error colors. I don't want to do that. I don't want to do that. I'm not going to do line numbers anymore. All good. MS exception cycle active right. This is a color. Oh, you know, we do have a REPL one. Should we blink when we're in the REPL? Exception. Red. I'm gonna delete this active right. I don't think I want to do that either. I have a lot of possible colors. Blink means pay attention. That's exactly what I'm saying, Gareth. That's you're hitting the nail on the head, right? Like I want it to be that like yeah, if it's blinking, something is happening. So like it needs your attention. Exactly right. Like it could be your code finished and that's fine. Or I think, yeah, that makes me think that we should blink in the REPL as well. Because if for some bug reason you end up in the REPL, like, or your serial output's not showing up, if it's blinking like white, and I think we'll do different blink counts as well. But yeah, I think these are the three colors we'll probably want a fourth one for Bluetooth. And then maybe we'll want like counts. I think I'll just do counts like 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. Like I think that would be simplest to do. No, I don't want to do Morse code. I want it to be simple to describe. So like 3 blinks. 3 blinks is this, 2 blinks is that. Yeah, Daniel says maybe they make the Bluetooth color blue. Uh-huh. That's why I'm not using blue here. I want to have like, I think if you start up, it'll be like a yellow pause, right? And if you click reset during that, that will be safe mode. But then that will be followed by like a blue pause. And like if you hit the blue pause, that will trigger you to go like restart and start up in pairing mode. Which is funny also because in pairing mode, I think we do want to do LED animations for some boards. DCD says perhaps the AR app could decode the colors for those that have color decode challenges. I think in general you just don't want to rely on any one way of doing it. And some folks are talking about Morse code, and I think that for boards that have a buzzer, that could actually be interesting as well. Like the Roomba that we have, if it's like off its charger and it's about to die, it will actually like make noise. So potentially the blink pattern that we create here, we could actually also do like buzzer pattern. And just like Gareth was talking about, like it only does it when it needs attention, sort of a thing. So I think what we want is, I think we're going to want count. So if we leave this stuff here, BIOS diagnostic beep. Yeah, we should see what patterns they do. I think maybe we want like a standard gap length. So, maybe we call it LED sleep time. And then blink time. And then maybe we want the number of blinks. So define all done blinks. 1. I'm a little worried about safe mode is probably gonna be the rarest, so I might make that 4. Exception blinks. So this is like the number of blinks. And I think the more blinks it is, the harder it is to count. REPL running. 3. Something simple like that. So if we do LED sleep time milliseconds, I think if our difference is less than that, right now for prototyping, in the long term, I think we'll actually want to sleep. If we can sleep, we should sleep. But for now, I think, oh, you know, this is LED sleep time. Tick animations. Maybe we do want total time. And we could also just set color up here. There's no reason for us to do this if statement every time. color. So basically what I'm thinking is like, we'll just collapse all this down into new status color. Status color. Too many blinks. How about gently breathing as an additional signal? The reason that I don't want to do gently breathing is because of battery use. Because I'm thinking about the blink count being like 5, 10, maybe even 30 seconds apart. Although I think 30 seconds is probably like, oh, I thought it was working, but like you have to think about how long you have to look at it to know. So like 5 seconds is maybe as long as you want. But yeah, I don't want to do breathing like this anymore. Because it's constantly, I mean, it's PWMing, but it's constantly on. And I'd like to, like, in order to do that, it's doing a tight loop, right, to do the animations. Whereas I'd rather just like straight up sleep as deep as we can for a while. Like do a sleep for 4 seconds, right? And then do some blinks, and sleep for 4 seconds and do some blinks. Because I am like, we've heard these cases of like, oh, I want to do low power stuff, but if it crashes, then it sucks more battery. Right. So I want it to be kind of this trade-off of like, it should be as frequent enough that you can see that it's broken, but not so frequent that like you're just going to suck all the battery down. And that's kind of what, again, I like what Gareth was talking about, is like you blink for attention. So color. And the reason to do this now is that now is a great time because we're early on in like the 7.0 cycle, relatively, I think. Need this. And I don't need this either. And then we're going to also do status blink count equals all done blinks, right? Yeah, DCD says the initial shipped demo code can blink to show off features of testing, but totally agree about having 5+ seconds between blinks. Yeah. Yeah, I think, you know, if you want some demo code to perhaps call HCF instead of blinking the LED, much easier to detect. HCF being halt and catch fire. I don't think our customers would like that if we were catching their stuff on fire. I love that show though. I'll just call it the Sparky. Safe mode blinks. Yep. David points out if it's monocolor, it'll also work with boards that have no RGB. So the RGB is not a mandatory CircuitPython feature. Yeah. Yeah, that's the idea. Is that the blinks would go on a monocolor one, which we do have definitions for already. Oh, and you know what? We don't have a REPL. Oh, the REPL doesn't... Blinking during the REPL is going to be harder. It'll be white for now. I don't need to do that now. Exception blinks. Blink and blink count. And it needs to go here. I think it's just... color blink count. We might want total time as well. Yeah, DCD says, should the function name change? Probably. I think you're right, because we'll want to, I can do this for prototyping on the stream. Like we only have like 15 minutes or so left, but I think that I think you're right in that I'll probably want to get rid of this. Like I did these functions for the purposes of like factoring them out, but I think I could actually probably move them back to where they were in the main.c file. And that would allow us to do the like longer sleep stuff, which is definitely something I want to do still. So yeah, this is subject to change, but let's just see if I can get it going. So I think what I want to do is actually, so the question is when do I want to restart the clock? So I think I want to restart the clock when the tick difference is greater than self total time. I'm thinking about what if we actually blinked at the start of the cycle and then slept. Blink and sleep, blink and sleep, blink and sleep. So this would then say if tick diff is greater than like total blink time, set it to black once, and then that will be the like sleep duration. I guess that won't happen once. Blink count times. Do we have a definition for how long the blinks are? One second blinks? No, I don't think. Maybe a tenth of a second. Blink time ms. So we're gonna do 2 times blink count times blink time ms. And then if tick diff divided by blink time ms self blink count. I'm trying to think of like my division versus mod. So I'm basically going to say like in one case we're black and in the other case we're the color. Right? Else. If we're less than blink time, we're good. And I'd like this to be right. So if we take tick diff and we divide it by the blink count, is that what we want? I don't think so. I think I want to actually divide it by 2 times the blink time. diff equals tick diff divided by 2 times blink time milliseconds. So that would give us which blink number we were on. So what if we do mod instead, and then blink diff greater than or equal to blink time. So in the second half of that time period, we're black, otherwise we're bright. And there's this weird period where, okay, I think that's right. Maybe? Probably not. Let's make it again. Nope. It's the blinking state machine. Each state is the list durations on and off. You just browse the list and sleep at the end. Yeah, we could do it that way if I wanted to be more generic. Oh, I didn't. REPL running blinks. It loves to load the file even though it didn't work. RGB status. Pattern start. Ooh, we do want a pattern start still. We do want that because that gives our tick diff. But then we have all these other things. 365. Nobody should be surprised that it didn't. Okay, so status okay. We don't need, we'll just do it here. We don't need found main, we don't need safe mode, we do need pattern start. New status color, let's not do that. Because we're gonna be blinking. Get us closer. Yep, it got us closer. Safe mode 365. So we don't want to pull it off status, but we do want to read it. I think humans often struggle with more than 2 or 3 blink patterns. That's why modems have so many LEDs rather than one multifunction one. Yeah, that's why. Above all else, the whole goal of this is just to what is it called in here? Above all else, it's just to say like, hey, like something's wrong. I think that was the, that's kind of what I'm reacting to, is like the idea that I was trying to just encode too much information. Let's turn off the flash flickering as well. External flash. Temp. Status color. As cool as that is, I don't think it's useful. Of course, it doesn't matter, besides being confusing, because if you're doing USB writes, you probably have power. I guess you could be on a laptop or something, but like if you have a laptop, we're not nowhere near the same amount. Brightness 387. Brightness here. Oh, where does brightness come Is that a... Is it passed in here? No. Slow blinking, fast blinking, 2 fast blinks, and then pause. Yeah, the other thing to consider is that we do blinking in the bootloader. So ideally, we wouldn't do the same sort of blinks that the bootloader does. that's not right. What brightness got used? Was it in the... Let's pull up the original version of this. Sign myself. I'm doing it. I'm doing it. I'm getting rid of all the fancy blinks. And supervisor shared. LED status. So where did the brightness come from? New status color doesn't have a brightness. Did I make that up? Oh, here we go. Oh, it's for the ramp. Okay, we don't need that. I think new status color actually accounts for like a global brightness. Sweet. Well, that's less math that we have to do in here. Where did my... Okay. No member total time. Total time, okay. We'll do this here. Total time equals status blink count times blink time milliseconds times 2 plus, what did we call the sleep time? Here. If you have to define the different sorts of blinks, then you have a problem. You're so right to simplify it. Yeah, that's what I'm getting at. It's just like, people understand it's trying to be helpful, but it's not helpful enough to actually be helpful. If that makes sense. 362. Ah. Oops. Like, we have better solutions now, too. Like, Adafruit can do an app for phones that will decode the blinking. BLE, the BLE is a much better option. 283. Main running, REPL running. Oh. I just want to delete those. Main. For now, main won't do status color. There. Fake sleep. That should be... maybe we'll set that just in case. Boot running we don't want. All right. Sure, there's a crowd that would appreciate the jlink right over the challenge of a Morse code stack trace. 4 fast blinks, 2 hearts, remember? I don't know. I'm missing the reference. All right, we compiled. Let's run it. Oh, we're getting our blink. The yellow blink is the charging. So this is every 2 seconds. I like how long the blink is. Does everybody... I don't know what frame rate you're getting on the stream, but like that rate, it seems pretty reasonable. But I think it could be a little bit more spaced apart. LED status colors. Right now it's 2. I wonder if 5 is okay. So let's reload. And then we'll do the we'll cause some errors here in just a sec. I was like, Slower exactly. How many lines of code just for a blink? That must be the most complex blink code example code. Yeah, but it's 2 blinks is often called a heartbeat, so 4 blinks would be a Time Lord heartbeat. Nice. I like that. This seems pretty reasonable to me. This is 5 seconds apart. Neardoc said, somebody mentioned that the board didn't come with a decoder ring when I explained the bootloader pattern on the S2. Press boot while the LED is purple. We actually have a good diagram. So this is every 5 seconds. I wonder if 10 seconds is probably too much. I don't think I'd go, I don't think I would want to go over 10. If folks have any last questions, now's the time to ask them, because I'm running out of steam. But I'll at least flick on USB and see how it goes. So it is nice that it blinked promptly. Like the way that we did the pattern, it blinks at the start. So it's not like it would like throw an exception and not blink for 10 seconds. It will blink immediately. So if I turn on the data, and so we don't get the flickering from the drive because we turn that off. It should be the deeply relaxed heartbeat of an athlete. Is that the description we should have in the 7.0 notes? The LED now is like a calming pace. Okay, so we are done. Is this configurable? So now we're in the REPL, and the white in the REPL is still going. Blinking faster and faster or slower and slower might be a message too. I think the problem with doing that is like if you have a pattern, you have to figure out how long it is. Bad Abby says, yeah, we could set that. I think that would be reasonable. We could just do like supervisor dot something, and then we could set the time between blinks. I think that would be okay. Like if you are doing a battery sensitive thing and you want to say like it's okay, just blink every minute or 10 minutes or never. I think that would be okay. All right, let me just iterate on this so I can cause some errors. Raise runtime error. How easy is that? Ooh. I like that. Just 2 quick red blinks. Oh, what's that, 2? Or what's that, 1? Yeah, that 10-second gap is a bit much, isn't it? But it does it immediately, right? So if you're iterating and you're trying to fix it, you'll get that blink feedback immediately. So there it is again. But see, if I hit Control S and I save it, I immediately get the like 2 blinks you threw an exception. Beta asks, what is the flickering? So the flickering is there's a second LED on here that's the charge LED, and it flickers like this because it's basically floating when you don't have a battery plugged in. So if you were actually doing like a battery sensitive application, you wouldn't have that flickering. Yeah. So nice. I wonder if I do import storage or supervisor, or let me just do it from the REPL. I was going to try to get into safe mode because that's the last thing that we did. I'm really liking this. Do folks are folks okay with this? Reload. Supervisor dot. How do I? Oh, run reason. No, not run reason. How do I set the? Oh, is it? It might be part of runtime. How do I go into safe mode? Folks thinks 10 is too long. What do you think? 5? 5 is better? I don't know, actually. I thought I could get into safe mode from user code, but maybe not. Five or 3, Toddbot says. Moto Timo says, simple is better. This is a good refactor. All right, let's eject. Bad Abby was going to say 4. Okay. I do kind of want to push it because the longer it is, the more you can sleep. Can we have a Python mockup code to discuss and test various Blink without recompiling CircuitPython? I'm going to leave that as a challenge to the reader. But I'll set it at like 5. And as we have betas, we can switch it. I'll set it to 5. Because I buy that 10 is a little long. I think 5 might be about right. I'll have to pick this up. I'll pick this up next week, and I'll post it as a draft on the stream here, even though we're a little late, just in case people want to play with it. But did I remember to shut my USB off? No. It can get. Oh, microcontroller.run mode. Thank you, Daniel. You would think I would remember that. Maybe the Blink code should be frozen Python code. No, the reason that is a frozen Python code is even bigger than C code. Okay, folks, we'll test this. Let me just reload debug. I'll load it with the 5-second gap. But I like that. Yeah, I think it's a little long, the 5 seconds, but it's not that long. And I would rather push it to be a little bit long. Because, like, I was also thinking it should be, like, long enough that you can say, like, count to 5, right? Like, 1 1000, 2 1000, 3, like, you could say, like, okay, like, how long does it take? Okay, let's try safe mode. As the last thing here, and then I'll push it so in case people want to try it. Where'd my TO go? There it is. Oh, microcontroller, that's my problem. On next reset, microcontroller, run mode, safe mode. How long should be the on time? Eyes can detect blink even if very short. Yeah, we could make that shorter. Right now it's 1/10 of a second. Ah, there's this bug. There's this like outstanding bug on NRF. So that's 4 quick blinks. I think the problem is we all think a second is shorter than it actually is. Do LED pattern rhythms. If it's the baseline to Jaws, it's a boot up high error. If it's Beethoven's Fifth, it's a problem in code up high. If it's the Peter Gunn spy theme, Wi-Fi couldn't connect. Do you think that's too... Is that too blinky? What is the flash rate for seizures? That would be worth thinking about. I always assumed it was... Yeah, I agree that it's like hard to count to 4. Oh, that hurt. Yeah, the other flash is the I think it is 4. Maybe one thing we could adjust is we could make the gap between the flashes longer. I don't really want to make the flashes themselves longer because that's like power usage. But one thing we could experiment was actually like spacing the flashes themselves further apart. Actually, let's just try that. I know we're over time. But I think what we do is we just make this 3. And then this total time is 3 as well. 1, 2, 3. Yeah. Charger. All right, we're just about done, folks. Thanks for hanging in with me. This is how it's done. This is the deep dive. We got our snorkels on. Last reload. So I think if my brain is right, this should... It's now 3... Like, the blink time is a 1/10 of a second still, but now it waits 2/10 of a second before blinking again. So it should be the same length of beep blink, but they're further apart. Which I think is better. Let's just get in safe mode again. Oh, you know what? Let me show you a trick. For those of you who have Circup Python compiling, if you go into, so we're in NRF, say you want to test it, you want to test safe mode, you can always fake it. Supervisor port. Tickinit, port init safe mode. So what you could do is you can cheat. If you want to test it without having to enter it. So this is just a, like, it's going to pretend to be a watchdog reset. So we'll reload. Todd says, I like that better. Yeah, good. The larger gap between blinks, I think that helps. And, right, like, I'm trying to optimize for how long the LED's on. It's okay if there's, like, more time spent off. How was that? Yeah, that was much better, wasn't it? We could even go even more aggressive. Do we want to... We could make it even further apart, maybe that. Should we try to even make those 4? I'm just kind of curious because that did help it. Let's just have a magic constant in 3 places that we update. Let's just try 4. It's A/B test the 2. I don't get that fancy. right. It definitely makes it feel... That's a smidge slow, maybe? Maybe not. How do we like that slow 4? What do folks think? Do you like that or the 3? Either way, I'll factor it out. Would blinking 2 alternating but close colors make it easier to count? No, we don't want to rely on 2. DCD Angie would say 4 is the best for me. Okay. What should we call it? We should factor it out. It's just like on fraction. I don't know what. Naming is so hard. It could be like off multiplier. It could be a ratio. On, off, ratio. 3? Or off, on, ratio. I think that's right. So it would be off, on, ratio. Plus 1. David says, wait, your web stream is 30 frames per second and it's filming an LED. Are we well positioned to judge the in-person impression? Comparing like what I'm seeing directly and what I'm seeing on the screen, it's fine. Like the rate of blinking is so low that I imagine it's okay. As long as we're getting the right 30 frames. Exactly. All right, let's just do one more compilation to make sure that's right. Easy to count at 4, does feel slightly slow but acceptable. Gap, LED blink gap. I think it will feel less slow if we turn the, actually let's do that too. Let's undo this safe mode thing. I have a feeling it won't feel as slow with just like the 2. You know, like the 2 red error. I think it will be. I think it's just the 4 where it's going to feel a little long. I think that's the longest pattern we have, so the shorter patterns won't feel as they won't feel as long. Yeah, it's just a boom, boom. Yeah, maybe it still feels a smidge slow, but I looked over, I only cut the last one. I think that's fine. All right, that's where I want to leave it. Let's push this code. I'll do it as a draft PR. Or I'll just do it as a branch. Look at all that delete. I do want to redo how it's working. And I'm curious to see how much space we save as well. Prototype. Simpler flash. I am happy with that though. That's good. All right. So if you do want to check it out, my branch will be here in just a second. I have to get my PGP. Oh, good. Show my last pass vault. don't think my password will actually show up. Okay. I am happy with that though. So there's a simplify status LED, and I want to make it also blink on, if there's no RGB LED, it should blink on the regular status LED as well, because there are some boards that have that but not the RGB LED. David asks, should the total blinking time be constant and the blink at different speeds to accommodate 1, 2, 3, or 4? I don't think it matters. I don't think, like, I see what you're saying, like the total blink time is going to change with the number of blinks at the end, but I'm more worried about like the gap, or like how long you have to wait to see it, which I think is fine. Less is more. It must hurt to delete your work, but that was the right decision, I think. It's fine. Like, I'm not wedded to my... I'm wedded to the overall quality of the project. I'm not wedded to any in particular thing. That code was always hairy, always kind of a pain to maintain. So I'm okay seeing it go. But I do want to... I'll take a fresh look with fresh eyes next week and probably rework how it's done. I might actually like suck that stuff out and put it back in main so that we can do a proper sleep instead of, like, right now what's happening is that function is going to be called a bunch and just do the same thing over again. So it's going to be transmitting a bunch of copies to the NeoPixel of the same value over and over and over again, which doesn't make any sense, right? Like, how do you stop your blinker, your white, and your REPL? So like, the REPL just has a set, and then the code that calls this animation stuff is not running during the REPL. So I think blinking in the REPL is going to be a separate challenge, but I think by integrating all the blink stuff back into the main.c, probably simplify all of it, which is a good thing. I bet someone has published a paper on UX study of error blink codes and blink rates. Yeah, maybe. If you find it, let me know. It's certainly, we're not the first people to do this. All right, let me pull up my thing and I gotta go downstairs where it's cooler. Hello, you can see me again. And you can see Spook in the window. All right, well, that has been another deep dive. Thank you all for hanging out when I was working on my blinks here. Even if you're a 10 plus years experienced programmer, you end up writing blink code still, apparently. It's been another great deep dive. As a reminder, I'm paid by Adafruit to work on CircuitPython and do all these streams and stuff. So please support them by going to adafruit.com. Reminder, we have now project bundles in the Learn Guide. So if you want to just download all the files all at once, you can. And it's easy, which is awesome. And thank you to the folks that made that happen. JP says stretch. Yeah, I definitely will. I'm going to go for a walk here shortly as well. If you want to chat with me and a bunch of other awesome people, join the Adafruit Discord server by going to the URL adafru.it/discord. And I think I didn't say this at the start, but next week I think is also planning on being on Friday. So that should be good. And yeah, I think that's it. I'll switch cams and give Spook some pets here, and then we'll call it a weekend, or a week, I guess. Thanks all for hanging out, and we'll see you next week. Spook. You love the sun, don't you? All right, good night, everyone. Have a great weekend.